My name is Martínez-Fernández, and I come from the Technical University of Catalonia in Barcelona. I have done this job with my advisors, Claudia, Ayala, and Xavier, Franch. And this has been done under a project with an IT consulting firm, which is called Deveris, and also Helena worked there. Well, the paper presents a reuse-based economic model for software reference architectures. The outline, the agenda for this presentation, I split it in 4 parts. I will start with an introduction, then I will present the economic model, how this economic model can be applied, and at the end some conclusions. So, not to bore you, we saw in the previous presentation what a software reference architecture is. So I will go directly to the motivation. What we have found in this company is that big businesses, big organizations such as banks, public administrations, industry companies, and so on, have a wide portfolio of application of software systems. And these applications share a business or technological domain. For instance, in a bank, we can find applications for checking the salary that we have in the bank account. For instance, in an application for the mobile phone, another one for the web, the desktop application that people who work in the bank have, and so on and so forth. And then organizations have the need to develop and maintain all this wide portfolio of software systems. And this is what they ask to consulting firms. And one way to approach this problem is the use of software reference architecture. There are 3 main goals that are, first, to standardize all the developments. Second, to interoperate all the applications, and third, to facilitate the development, to give help to developers. So, if we think that the software architecture is like a metaphor, like the structure or organization of a house, each application could be a house. What we are thinking is trying to imagine that you are the city planner of a city, and then each house is an application of the organization, and there are 2 things that the software reference architecture try to standardize. The common elements, which would be the swimming pool or the roads, that all the applications or the houses use them, and then you also facilitate common elements of the applications. But of course, there are differences between the houses. One of them are white, other oranges. Some of them have 2 flats, 2 floors, other 3, and so on. Advantages that this has is that it facilitates reuse and reduce costs, cycle times, risk, increased quality, standardization and interoperability, as I mentioned. One important one, that the software reference architecture allows different organizations to work in the same project, because all the applications are based in the same architecture. In the bad side is the upfront investment in the reference architecture and the adequacy of the architecture for the organization applications. So what we focus is in the reduced cost of a software reference architecture program and the initial investment. And the research question that we try to solve is if it's worth to invest on the adoption of a software reference architecture. If we should go to a software reference architecture program or not. And this is more or less related to the panel of yesterday that we were discussing about the ROI of reusing programs or architecture-centric programs. So this is what we are trying to solve. The goal then is to formulate an economic model for software reference architectures. Up to our knowledge, we didn't find anyone, but of course there are a lot of jobs in the software product line field of research, and therefore we attempt to adapt all these cost and benefit factors to the software reference architecture, since some of the principles are similar. And we also try to do them easy to apply by the industry, in order that the economic model can be applied easily by practitioners. The second thing that we take into account is there are also methods like PBAM to make decision making in software architecture, but we want to go a little bit further. Something more specific for software reference architectures, and also we have used some generic software metrics to complete the model. So as I mentioned, this work has been done with a consulting firm, with Everest. We are performing active research, and we will see an application of the economic model in a real organization, in a public administration in Spain, and how it works. So let's go to the second part of the presentation, the economic model. While we were creating this economic model, we followed 3 steps. The first one was to identify the costs and benefits of applying a software reference architecture. We use existing metrics from Pauline and Clemens, and we split the costs and benefits into sides. On the one hand, the software reference architecture, and on the other hand, the unit cost for applications. So if we think in a modular design of an architecture, this could be the software reference architecture, and these little rectangles, each module of the architecture, we identified 3 different costs. The first one, the cost to develop all these modules. The second one, the service or maintaining cost. And the third one, evolution cost of adding new functionality or changing existing one. And on the other hand, in the part of the application, we can think that this is an application, second application, third application, and here we have the modules that we reuse from the software. Yeah.
There's one question. So when you say reference architecture, you're including specific components as part of the architecture.
Yeah.
And the development of those components.
Yeah, we distinguish between reference model and reference architecture. For us, the reference model is like the
diagram.
The diagram.
Okay. Just wanted to check.
So this would be a reuse module, and this unique functionality or unique code of the application. So we have 2 benefits that are the cost avoidance of developing a module from the reference architecture, and the maintenance cost avoidance of reusing the module, since this is done in the left part, and then the unique cost of developing the own functionality of the application. So let's go to the second step. That is now we have identified 6 cost benefit factors, but we don't know what's their value. So what we are trying to do in the second step is to find easy metrics that can be used by practitioners to try to estimate these cost and benefit factors. What we found that industry having normal projects is effort metrics to calculate the project costs, and also software metrics to calculate the benefits, for instance, from reuse. On the other hand, we found that it was very difficult to find historical data, especially for the before state. If we are comparing the creation of applications based on the software reference architecture or in a standalone fashion, a real company cannot afford to develop the applications first with the architecture and then without it and compare it. So we needed to find some other way to calculate it. And therefore we have 10 basic parameters to calculate the aforementioned 6 cost-benefit factor. These 10 parameters are basic, and they are well known from powering. Some of them are reused from powering, others from Corman. For instance, the relative cost of reuse and the relative cost of relative for reuse, or the propagation cost of in a modular design. And with these 10 parameters, we can calculate each one of the cost benefit factors. We will see it later in the application of the model. So now the third step of the economic model is making the business case. As it said, a business case are the materials prepared for decision makers to show that the idea being considered is a good one, and that the numbers that surround it make financial sense. So it seems that the business case is the perfect tool or that can be used to justify an investment. In our case, to justify the investment in the software reference architecture. For that, we need to know some other parameters, such as the years of the software reference architecture program, the number and size of applications that are in the roadmap of the architecture program, the possible evolve or new modules, and overall rates for software architects and applications. So now we have the model, but how can we use all this to calculate the return on investment? We took this formula from Boehm to compute the return on investment, and then we use our benefit factors and cost factors to calculate the return on investment. So let's see how all this has been applied in the application of REARM. And I said before, we apply this economic model in an organization. By the time that we arrive to the organization, everybody is already created a software reference architecture for them, and they develop an application based on the software reference architecture and fix the bugs that they found in these reuse modules. So we could take the basic 10 parameters that I was mentioning before. The first one is the cost that kilo line of codes, the amount of hours that of creating 1,000 of line of codes, and then the cost benefit factors. For instance, for the common software development costs, we took the total source or the lines of code and multiply it by the number of hours and the relative cost of writing for reuse, the extra cost that implies writing for reuse. And this is the upfront investment in the software reference architecture. In this way, we also calculate the maintenance costs, evolution costs. These 3 ones are for the architecture, and these 3 ones for each application. So we see that the investment is really high, but also if a lot of applications are based on the reference architecture, we can get a positive ROI. So now we need to create the base case parameters. The first one is the size and complexity of future applications, since they already develop one application, we assume that all applications will have the same complexity and size as this one, although it's not the best case. The portfolio of applications per year, we assume in the roadmap they plan to create 8 applications per year. Then the maintenance cost, the future ones, we have compute them proportionally with the data that we have with existing maintenance cost. Then they are going to create a new module, a new ever module every year in the software reference architecture, and they are only rate for employees. So with this we created 2 scenarios. The first one is if it's worth to invest on the option of a software reference architecture. Here we see the cost and benefits per year in a 3-year program, and the green line is the sum of the cost, the benefits minus the cost. So in the second year, we see that the ROI is already positive, and in the third year is 42%. So it would be a good decision. It has been a good decision for this company to adopt the software reference architecture. And in the second scenario, we wanted to know how many applications are necessary before savings pay off the upfront investment in the software reference architecture. We found with a payback period of 16 months, and after 7 applications. Here we see the cash flow. So in the beginning, it was the investment, the first 6 months, and then it started to, with every these are the number of applications, 1, 2, 3, 4. With each application, the organization gets benefits. For the maintenance cost in the beginning of each year, and for the evolution, that flat points because of the inversion. However, the application that we use as a central application is a very small application, and that's why maybe this number is that big, because we were saying before that it should be around 3. And these applications only use 15% of the architecture, since it was the first one. And another benefit of using a software reference architecture is not only the ROI, but also the time to market. The applications, once that they start to be developed, because of reuse, there is a fault avoidance of almost 600 hours, and they get into the market early.
So are these real data, or is this a projection of what would happen?
This is real data until here.
Okay, so we don't know yet whether it's really paying off in the way we think.
No.
Okay.
No.
So this is really a synthetic analysis, what it might be if all the assumptions were true. Okay.
And this is exactly what we are going to see now in the conclusions. So how accurate are these calculations and obtain quantitative data? Well, on the one hand, if we have existing data to use the model, to apply the model, it seems that it is trustworthy because the metrics coming from the analysis of the code do not reflect any error, and they are completely exact. And for the cost, the time tracking that we were using Jira, well, they use Jira in Everest. It seems reliable because they use time tracking the developers. Once that they perform an activity, they put the amount of time that they invested, and also the project managers to control them to see how much they are working. And in these 2 data, there was only a difference of almost 9%. But on the other hand, if we use when we don't have existing data and we need to use predictions, assumptions, the output of the economic model depends on expert intuition and historical data, which can be very difficult to get. For instance, the complexity and size of future applications, we do not know it, and there could be, they are just estimations. So this is the challenge, how to validate the output of the economic model. So the conclusions is that in the beginning we had a research question that was to see, try to formulate an economic model to translate from the measured data, the metrics, into monetary terms. And then with the economic data, with the economic model, we analyze the economic value of a software reference architecture. And then client organizations or acquisitions organizations of a software reference architecture can see if it fits in the business strategy. So the strengths and weaknesses of the work is that we translate cost and benefits, qualitative cost and benefits into monetary values for the business people. We integrate metrics from software product lines and normal general metric of software models. We provide guidelines for practitioners so that they can really apply the model and that it has been already applied in a public organization. On the other hand, the maintenance, the way in which we calculate the maintenance cost do not consider software elements the generation over time, and the risk increases when we don't have real data to use the model. So as future work, we plan to add more metrics to the model, such as technical depth, the generation over time, risk metrics, and homogeneity metrics. We are also applying REARM in another organization now. We need also to validate if the output of the economic model is correct. And this has been all. Thank you for listening.
We have some time for questions. Why don't we take some questions and comments?
There's also a lot of work on return on investment in development.
Yeah.
But I mean, like when I'm hearing your talk, it's like the hand could easily be also return on investment product lines as well, right? Software product lines.
Well,
is there any reason why you say return on investment on software return side?
Because we think that